Me with my hand in the air. If you can see my hand, oh, look at that. Well, I'm doing my best to speak up. My microphone isn't quite cutting it. And I want to speak loudly enough to get everybody in this room, but not so loud that I blow Mel's ear out and everybody on the internet. We're doing good? Okay. Levels are attenuated. Thank you, everybody, for joining us for another OWASP Ottawa monthly meetup. This is a fantastic turnout tonight. By show of hands, who's here for the first time? Well, I guess, wow, that's like mostly, maybe half of the room. That's fantastic. By show of hands, who's here for the pizza? Okay, but it's not just the pizzas. We're doing okay. My name is Adam. I'm an organizer here for OWASP Ottawa. I am one of many who help to keep this community moving forward month to month, week to week. If you're an organizer, can you just put up your hand? These are your organizers. If you see somebody here, say thank you. And if you'd like to join us on Slack. We love to have members of our community as well as more organizers on the team. We are working really hard to rebuild, well, to continue to build this chapter here in Ottawa to a point that we've got some good self-sufficiency, redundancy, business continuity, and what have you. So if you're interested, please speak with any of us as organizers. Find us on Slack. And that's that. Other housekeeping items. Washrooms. Out this door, past the elevators and to the left, down that hall. It's a fairly long way, so make sure you have enough time. If anybody knows of a closer washroom, I'm not an expert in this building, but that's the one that I know of. Beyond that, I think we're roughly ready to get started. I gotta thank Greg. Greg and Rewind, every month there is a fantastic stack of pizza that's hanging out at the back of this room when I get in here. And they tell me that it comes from Greg and the team at Rewind. So how about a big round of applause for Greg? So, secrets. This is not a secret. I'm gonna ask this one more question. How many people had to climb over a snowbank greater than 8 feet tall to get here tonight?
For once, I did.
Okay. You got plowed out. You're doing better than we have on our street. We are definitely at the bottom of their list. And so I literally, they're like 12 feet. Can't see going out the driveway, but that's not why we're here today. I'm happy that this many people were able to make it out here, or maybe it was just you couldn't make it home. Can we try to get Robert? Can you get your slide itself up here? Robert is here to talk to us about secrets. And one of my most exciting moments, I think it was literally the first time I ever fired up Burp. And I pointed it at something that I had the right to point it at, not expecting to really find anything because I was just poking around. And the first thing I found was something I definitely shouldn't have found. And it was in that moment that I remember, oh yeah, not only are secrets and secret management important, but even when you think you've got it sorted, maybe you don't, because it's complicated and it's hard. Robert Babayev, you've got some expertise here, and you're gonna share with us a little bit about how we might wanna think about effective management of our secrets and why.
Absolutely.
Take it away.
Thank you. Testing. Okay, I hear the difference. I used to be in theater, so technically speaking, if this goes offline, it's not as much of a problem, but I am fighting off a bit of a cold. Got it on Friday and mostly in recovery, so don't feel too worried, but that is why I have a mask on. Anyways, so I'm Robert. I've been doing security stuff for the last 5 or so years. Everything from application security, penetration testing, security engineering, a little bit of SOC analyst work, not as much, but eventually I found myself in the realm of secure development with a security context. That's how I've been marketing myself for the last 6 months, I want to say. And that is kind of why we're going the route we're going today. I've been dealing a lot. Oh, yep.
It's not working for some reason.
Oh, no, I haven't pressed anything.
Oh, sorry. Sorry.
No, it's okay. It's okay. I'd be looking a little bit more frustrated if it wasn't working. Where was I going with that? Essentially, we're looking at application secrets because I've been having to deal with those for the last, well, basically 5 years. Now, I'm going to start by showing you something that might be a little bit controversial. Okay, it's probably going to spark some discussion, get some discussion going. And I really appreciate having diverse, valued opinions. So I'm curious to see what people have to say on this. Completely agree, yes. So managing secrets is extremely, actually, this is a bit of an understatement. Managing secrets is actually extremely difficult. Managing secrets is one of the things that many people don't think about. And if you want evidence of that, go to literally any documentation page for any programming language ever. And if they actually mention environment variables once and it's not in a dedicated section about environment variables, give them a cookie. Just straight up, like go up to the developer's house and then give them a cookie. Don't worry about how to do that. That's your problem. But the agenda for today, we're going to look at my first approach, my actual personal first approach to secrets management. Now, note this is in an application security context, so we're not really going into information security. We're purely focusing on, how do you make sure that whatever configuration or API secrets or whatnot you need don't get into the wrong hands, especially in the context of things like having your code on GitHub or having Docker images, things like that. So we're going to talk about 5 different tips and tricks, and then also because I realized after Adam's wonderful story about Burp Suite, I realized I've forgot something in the slides, but we'll go over that when it comes to that. So first things first, what is a secret, right? A secret is a very simple definition, anything that you don't want a random person to get access to. That's my own personal definition. However, it might change from person to person, but this is, generally speaking, in my experience, this is what a secret boils down to. For a developer or a security practitioner, secrets can be API keys, JWT signing secrets, passwords, credentials, encryption and decryption keys. So an API key, specifically, is something that you pass along to some API. Now, an API can be, for instance, if you've ever worked with Spotify, right? If you're trying to write some code to switch out your playlists or grab your top 10 songs or what have you, you're probably using an API to do that, right? And so if you're using an API, you have to pass along an API key in order to get the application to realize, oh, hey, this is this one random guy who is building this application to get his top 10 songs on Spotify. JWTs, if you're not in web development, don't worry too much about this. These are basically things that allow you to actually have an authentication system that is not reliant on cookies. Passwords, fairly obvious. Credentials are kind of passwords, but more broad. These can take any kind of form. And then encryption and decryption keys. So these are any kind of string where you might want to scramble or otherwise encrypt, and then unscramble or decrypt a piece of data. So these are all things that you might run into in terms of secrets. So my first approach. Also, if you folks have any questions, feel free to raise your hand at any time. I'm happy to, go. As I say that.
What's the difference between, or if there's any difference between API key and app key?
So an app key. What are you talking about when you say an app key? Okay, yeah. So he's asking about OAuth applications, and I'd say that kind of falls under it because you do have to like pass that into an API. At the end of the day, I think OAuth is technically an API. It's just not a conventional API. Good question though. So my first approach to secrets management. So in first year, I really hated passwords. In fact, I still hate passwords. This is why I have a 54-character password to get into my password manager, but that's beside the point. I really hated typing in my passwords during university, especially during my first year. It was super error prone, and this was like only like a 14-character, 15-character password, which is no. This would have been closer to like 8 to 10. So 8 characters with all sorts of like weird little uppercase, lowercase numbers. Like, am I starting to drum up some memories for you in terms of entering horrible passwords? So I wanted to be able to access my university portal a little bit more easily. And since this was first year and a computer science degree, I said, hey, you know what? Let's make a Python script. And there's this wonderful book, Automate the Boring Stuff. Yeah. Automate the Boring Stuff with Python. It's by Al Swigart. It's available entirely for free in web format. Literally just look up Automate the Boring Stuff. First result you see, and you'll be able to get some great tasks going in there. And one of the tasks there was actually automating browser interactions. So like going to a web page, clicking on buttons, filling in text forms. So that was great, right? So I was able to get some code up, write up a script that would let me log into my university portal with my username and password. And then I put that up on GitHub. So are we leak free yet? Really should not have put the answer in the thing, should I? So no, definitely we are not leak free. Actually, this is an approximation of the script that I wrote when I was in first year. And I realized that even though I had set the repository to private, no, I didn't, because I wanted this script to go into my portfolio, which is even worse. So I had a public GitHub repository, which would have been my portfolio, which had a script, which had my university login and password in that. So understandably, I panicked a little bit, and I tried to figure out how to undo a GitHub commit. However, unfortunately, one of my mentors at the time, his name was Forrest. He basically said, "Yeah, you know what? Once you have a credential in GitHub, you might as well treat it as compromised." So I had already pushed the changes. Basically, like I wound up deleting the code and rotating my password after that. So not great. And if you can extrapolate that to, you know, however many thousands of dollars of API credentials might be lurking in a code base somewhere, if you're hard coding these credentials, which is actually what this is called, then that's even more of a risk, right? Somebody gets access to that. It might not just be, you know, somebody can mess with your university emails. It might be at some point that somebody racks up your AWS bill to like $1 million and you can't do jack about it. So let's play a game. I'm not entirely sure if this is going to be large enough to see from the back. However, there is a QR code that is definitely large enough to scan from the back, I think. So let's play a game, and I want to see if you folks can spot the leak or leaks that are in this piece of code yourselves.
Sorry.
What's up?
The link is not valid.
The link's not valid. Son of a gun. I know exactly why that link is not valid, and it took until you scanning it for me to realize. The repo that this is attached to is private. So, okay, scratch that plan. Okay, so for the folks in the back, how well can you see this? Okay, a lot more thumbs up than thumbs down. So, I'm gonna give you about a minute, scan through this section of code. I wanna see if you can tell me where the leak is, or leaks are. Just give folks about 30 more seconds here. Yeah, the repository this is attached to is private, so that's entirely my bad. All right. Yeah, sorry, private repository. We're working with it. We're working with it. All right. So time's up. You, I believe, had a guess. Yep, that's about right. That's yeah, that's leak number 1. Where's leak number 2? Yeah. So, what's your name? Noor. So Noor managed to catch the first secret, and that is this app.use session secret, and then this long string of characters. That is hard-coded secret number 1. That is leak number 1. Any ideas as to what the other one might be? Okay, a bunch of hands went up at the same time. I think you in the white shirt, I saw you first. No, actually, because technically speaking, having a port number isn't necessarily a leak. The only time that could be a leak is if, say there's something really sensitive and like internal behind that port. But at the same time, having that exposed on its own should not be a problem, assuming your firewall rules are good, your access control is good, all sorts of that stuff. So that in itself is not a leak. Good attempt though. Okay, a couple hands went down over here. In the gray shirt? Yeah, yep.
I'm gonna guess that if session is like accessible outside of the running environment, like the session in the memory, you need that if you're holding the secret, and it's not like a one-time use thing.
Okay, so to give you a little bit more context around this code, connect MongoDB session, that's actually using a Mongo database for the session like tokens, I think. I think that's how it does it. I need to go back and review the code on how it does that, but essentially, so not, I mean, if you had your database access control poorly configured, maybe you have it like exposed. Actually, did anyone hear about the whole DeepSeek ClickDB exposure a while ago? Okay, so I'm getting some nods here. Basically what happened was DeepSeek had one of their internal databases completely exposed to the public internet with no authentication whatsoever, and had a bunch of their data just right for the taking. So yeah, so if you have a database like that, then I could definitely see some cause for concern there. And you had your hand up? Close, actually. I'll just give this one. It's actually here, technically speaking. Now, why is it here? In this example, it's not quite the best, obviously. But, so a couple of folks in the back started laughing. Now, why is this? In this case, it's not that bad, right? Because it's just a local host instance. It's running locally. Like, this is off of a school project that I did. In case that doesn't explain the atrocious formatting up here. But let's say in my more modern projects, I have like a Supabase URL, right? And that actually has the username and the password embedded into the URL directly. You hard code that, it's as bad as doing this. So Database URLs are also something that you're going to want to protect, especially if they're not just Postgres at localhost port 5432/Postgres. And if any of you got that joke, congratulations, you've been in web development for over a year. Recommendation as far as things like this go, secret scanners. Tanya Jonka came in here, gave a great talk about DevSecOps in December. And one of the things she recommended was actually secret scanners, and I wholeheartedly agree. Essentially, all they do is they check for hard-coded secrets in your code base. So again, API keys, database URLs, passwords, credentials, anything like that. Usually, you do these checks before you make a pull request and a PR, or if you're more familiar with GitLab, merge request, pick your poison in terms of platform of choice. I personally run GitGuardian. However, others exist. Just kind of pick one, make sure it fits your use case, and then run with it. There are some other recommendations as far as DevSecOps, but I want to specifically zero in on secrets management. So, level 2. After that whole fiasco, I wound up getting into web development, right? And so this school project, I really wasn't concerned about security as much. And then I got into an actual internship doing web development work. I was working with Django, Angular, SvelteKit, all these sorts of things. And so what wound up happening was I started getting very, very familiar with .envs. So naturally, I've called this section using your environment. So environment variables are, for context, the environment is anything, well, funny I mentioned that. The environment is the context surrounding a running program. So this is basically just like everything kind of wrapping around that, everything wrapping around your web server is your environment. And the variables, the environment variables, are data in the environment that can change. So if you've ever worked with, what's a common use case? The node env environment variable. So like there's a string that gets set to either dev, production, test, something like that. That's an environment variable. It actually literally determines which environment you're in. So what winds up happening is because these environment variables tend to change, it's actually better to use these than hard coding them into your application. So these environment variables, they can actually be internal or they can be external, but just passed in. So a .env file, which is where the .env from the title comes from, is essentially a preloaded set of environment variables that you can load into your application when it boots up. Now, note, you should never commit a loaded .env file. Loaded means essentially full of secrets. So API keys, database URLs, passwords, again, the whole commit. You all know what a secret is by this point. So one good thing to do is actually make a .env.example with a whole bunch of dummy data that will never ever bother you if it leaves the right hands ever. And then anytime someone joins onto your project, they can just copy that .env.example and then fill it with the proper data in an environment that is actually ignored by your .getignore. How many folks are actually unfamiliar? Sorry, you had a question first? Sure. How many folks are actually not familiar with the getignore? Okay, 0 hands went up. Good. We're in a good spot. Go ahead.
How would you pass that .env? You said you can pass.
So there are a few ways of doing that, and it depends on the context. So that's why I'm not going to go into that here. I did link one way of doing it for Python specifically into whatchamacallit, into the resources package I have at the end of this. But there are tons of resources online, like literally just look up how do I work with a .env file in, I don't know, JavaScript or C# or what have you, right? You'll be able to find some stuff there. Good question. So for example, this is a .env.example. So just kind of gives you the basic outline of what variables you need, and then maybe some example on how they might look like. And then you can just populate those. Then once you have your actual data, you copy that into a .env file like we have here, and then you just pull everything in there. So, are we leak free yet? A little trickier, huh? So, for context, so just to give a little bit of background on these two pieces of code, this is actually from one of my applications called Courseful. It's been my pet project for the last 10 months or so. And this was when I had to literally manually hack together an endpoint to delete a user account from Supabase. Supabase being just this database backend as a service thing. So you got database authentication, things like that. And this is actually from the client side of that code, where we're actually working with creating a Supabase client and then working with the authentication this way. So one thing to note, the next public thing here, this is actually a really important pattern, because if you're working in a framework like, let's say, either Next.js, Nuxt, SvelteKit, anything where you might have code that is written in the backend and front end in the same language, it's actually really important to differentiate which of these environment variables should be seen in the client and which of these shouldn't. Reason why I mentioned this endpoint in particular, this was because deleting a user in Supabase actually requires something called something that is known as the Supabase service key. Now, Robert, why couldn't you have just chucked this in the front end and made your life easier with JavaScript? Great question. No, because the problem with this is the Supabase service key is an admin level credential, right? So it is not something you want exposed. And if you're working in a framework that compiles JavaScript into a bundle, those environment variables, granted, I'm not entirely sure if this is true or not, because I wasn't risking it, but if you get into that JavaScript bundle, by default, the next public environment variables are going to be in there. And then other environment variables are only going to be used for whatever backend you're in, right? So this is working with Next.js in particular here, but different frameworks might have different frames of reference on that front. So where was I going with that? Yeah, so the problem was, if I had marked this Supabase service key as a next public variable, what do you think would have happened? If I'd, gone in and bundled up all that code and just said, okay, there's this one client here that I can give a super level credential to. In the back, Garth? Yep, it would have been exposed to the client. Now, this wouldn't have been as obvious, right? It would not have been as obvious as one of the times where I literally saw someone logging out their e-commerce API key into the JavaScript console. Thank goodness that wasn't a professional project, because, oh boy, I would have torn them a new one if I'd discovered that on an actual pen test. But no, this would have been a lot sneakier. It would have been much trickier to detect, but still, considering that JavaScript bundle would have been accessible from the browser, you would have had to have it load in, and then from there, they would have had access to your super level credential that should have stayed on the server. Same goes for any kind of credential that you might need to stay on the server side, database URLs especially. So that's a little bit about that. Now, back to env files specifically. How do you actually keep track of these things? Serious question. Because like env files are fine, right? if assuming like the outside of your server is like decently secure, then it's going to be tricky to get into where these environment variables are actually located, right? So the only thing is, well, there are two things. First of all, somebody needs to actually hang on to that .env file, right? I mean, sure, you could just have everybody just manually copy paste things, but then you'd still have to be slinging credentials around, and that's no good. Like, how many of you folks have ever been in a situation where you're in your Slack or your Microsoft Teams or whatever, and somebody just sends you an API credential in the clear, just through one of your messages? See, okay. Huh? Okay, they deleted it afterwards, which is good. I like a little bit more of a guarantee than that. But yeah, I did see some hands. But guarantee that we've all done it at least once, right? Where we've sent somebody an API key just because, hey, we didn't have much better option. Now, to that end, you also can't just keep it on a Google Drive somewhere, because what happens if somebody slips up with permissions on that, and then that's a whole mess. So how do we fix that? Whoop. Wrong direction on that. Well, that brings us to a section I like to call, all right then, keep your secrets. So, secrets management, there are a few ways that you can do this. In the sense of having environment variables in places that are not necessarily an environment, a .env file. So deployment platforms like Vercel are probably the first thing that are going to pop up when you see something like this. They have native ways of actually giving you, they essentially allow you to enter your environment variables directly in there. They'll keep them locked down, and then they'll just pass them into the program, and Bob's your uncle, right? Similarly, CI/CD platforms like GitHub Actions, they also allow you to do this. So specifically GitHub Actions, I don't have a whole lot of experience with other platforms, admittedly, but I know GitHub Actions, they allow you to define what are secrets and what are environment variables, and I'll get to why that distinction is important in a little bit. And then you also have things like dedicated secrets managers. So HashiCorp Vault, the 1Password CLI, Bitwarden secrets, Azure Key Vaults. There are tons of them, right? They're getting more and more diverse by the day. But they're also something really, really good to keep in your back pocket as well. So cloud platforms and CI/CD. So this is kind of what they look like. So whenever you have like a deploy job, then you might need to pass in some data. So this is where, so I've got some Terraform config here. Basic gist of this is, you keep your secrets in this little nook here, fill all this out, and then you use them just by referencing them in your actual workflows. Main benefit here is that you don't have to be as concerned with slinging files around, at least in your testing, staging, and production environments, and your QA environment if you're enterprise. So that's kind of like one approach. And then as far as environment variables go, that's where, they're not like secrets. You just don't want to have to deal with like passing them in a weird way, right? So for instance, so this is stuff like your application port number, right? This is stuff like your application name, your base URL, things like that. Things that might change with the environment, but that aren't necessarily something you have to keep with a paranoid look on your face from the entire world. Oh, I'm really not used to this thing. So, convex. Remember when I said you're going to want to keep environment variables and secrets separate? Why do you think I highlighted that line? Sorry? That is the signing key. That is correct. Now, this is the environment variables section of Convex. You'll notice that I was able to actually view my environment variable after I'd set it. You want to know the word? Want to know a funnier part? This wasn't even like the day I actually set the thing. This was like a month after I checked in, and I could still actually view it. Now, why might this be a problem, right? If you've ever used anything like GitHub Actions or like DigitalOcean environment variables on their app platform or AWS or Azure or what have you, then you'll probably notice that like, hey, I can't really like view my secrets after I've created them. Same deal with generating API keys. On any decent platform, you can't really view your API key after you've generated it. Granted, there are different threat models, but generally speaking, in the more high security aspects, once you create a secret, you have to copy it down and make it sure it's somewhere safe. Otherwise, you're just gonna have to regenerate it. And that is the approach that I like when it's something like your JWT private key, which literally signs off all of your authentication requests. And if it were leaked, would allow any single user to impersonate any user with that key to impersonate any other user. Horrifying, isn't it? So the only reason I show you this is to just be wary, right? Know what platform you're using and know what the risks are, right? Because, like I said, this I haven't found a way to exploit this yet, because like as far as I could tell, like this was tied to my account. But if somebody else was able to get into my account and then see that, I'd be in for a whole world of hurt. So just be cautious. So the 1Password CLI, this is kind of where things get a little bit interesting. So this is the 1Password CLI is just one example, but it's an example that's particularly interesting. So what it does is it allows you to replace values in your code with tokens, right? It's a process called tokenization. All that is you swap a sensitive piece of data for something that represents it, right? So here in particular, we have these URLs. And you'll notice here that JWT secret. So if I were to just chuck this into a GitHub repository, literally nobody would be able to get this, right? Unless they had access to the specific 1Password vault that this is in, and we're able to realize that, oh yeah, this is the 1Password CLI that is using. But the more important thing is they have to have access to the 1Password vault, right? So now for context, 1Password, if you've never heard of it, is a password manager. It's paid, however, it is also really, really good for the money. For clarity, none of this talk is sponsored, by the way. I did not take money to come here or talk about any of these things. I've just been interacting with these things for a while to become comfortable with them. So the thing about the 1Password CLI is this literally allows you to run your application and swap in these tokens with their real files. And then, even better, it actually prevents you from leaking them out into your logs. So that's a really, really handy feature of that. And so this is actually what I've been using to run a lot of my programs. Courseful in particular, I had to re-architect a little bit of that, but I was able to get it to run using the 1Password CLI here, right? So, so this is kind of what that looks like. Obviously, there are different flavors of secrets managers. Again, I mentioned HashiCorp Vault, Bitwarden Secrets. Bitwarden also, if you're looking for free and open source password manager, really good, recommend that. But yeah. So now, are we leak-free yet? You're probably wondering why I'm even still asking that question. So unfortunately, things don't stop there. Because we live in a complex world full of complexities, sometimes we need to package things up in nice, neat little ways, right? So container images, those need building. And actually, I'm going to talk about those next. So let's talk about containers. So my first encounter with containers was actually in the same place I first encountered .env files. So what wound up happening was, again, I got into interacting with a Docker Compose environment, had to spend a lot more time than I ever should have fiddling with a Docker file, which was actually great because that gave me a lot of experience. And then when it came time to work on Courseful, I had to figure out, okay, how do I prevent the secrets in this image from getting out? Because for context, Docker is a very, very nice tool that prevents this exact situation. They define a consistent environment in which to run a program. Oh, consistent environments, environment variables. And you'd be correct to make that connection. A lot of the times you do pass in environment variables into a Docker container, and then you're able to get those in, right? So the problem is .env files and secrets managers aren't enough. So the reason for this is you need to build the image first, right? And well, if you have to build the image, then what happens to whatever value you pass in, right? Because like you're passing in the secret, right, into the image, and then that's getting built. And then chances are there's some container registry that's hosting the thing. I mean, it might be private, might not, you never know. Guess where the secrets are? Bingo, in the metadata of the image. Well, potentially in the image itself, right? So yeah, if somebody gets curious enough to go on Docker Hub or wherever you're hosting your image and pokes through that, they might just find all the things you don't want them to find. So for Docker specifically, there are two kinds of secrets. There are build secrets and there are runtime secrets. So these secrets you can access at, on Linux, it's /run/secrets secret name. I think that got truncated a little bit weird. And then runtimes, so build secrets are essentially secrets they pass in at build time. So they're just need to build the image, and then you don't really need them anymore after you're done. These you can just do with a normal Docker build. No fancy components required. Runtime secrets are a little bit trickier. Usually these need Swarm and Compose, and I won't go into as much detail on those. But again, I've tried to link, I've linked some resources on working with secrets in Docker at the end. So Docker secrets, these are basically just straight from the docs. They look like this. So when you build, you pass in like a secret parameter, and then when you're referencing that, you have to do this slightly gross thing. But after that, you're good. So again, it is a little bit more effort to actually get your build secrets up and running, but it's honestly better than risking somebody breaking into your container registry and then poking through your image and then getting the secret and then losing, I don't know, a $69 a month API key, which true story, and you're gonna get that in a few minutes. So this is kind of actually how I got, whatchamacallit. So this is actually kind of how I have it in Courseful. This is the entry point script for the actual application. And you can see we're kind of working with, so we're grabbing the value out of that file that the application essentially just stuck the secret into. And then we're using that to run the secrets manager and then calling the .env file. And then finally, we're actually running the command. So for 1Password, the OP service account token, this is basically just a way of saying, hey, I need to run my 1Password command in a CLI, and I really can't get into a desktop environment. So please, for the love of God, do not open up that little window that says, hey, this application is trying to use your secret. Do you want it to? The amount of times that I've had to deal with that. Anyways, so that's kind of how that can look. Recommendations. So obviously using them in tandem with a secrets manager, using them in tandem with a .env file is even better. However, it's also entirely possible to just swap out the secrets that are in your code directly. There's also a use case for that. Just kind of depends on what you want to do with it. I'd also recommend using them in tandem with the CI/CD, primarily because it avoids the last mile problem that I keep having with Courseful, and then I need to actually set up a CI/CD pipeline for the app, but that's an entirely different story. Just if you're already using a CI/CD pipeline, throw in some Docker throw in some Docker secrets into your runtime, and watch your security team thank you, or not. You know, I will. That remains to be seen. Now, last section. Most developers are unlikely to run into this, admittedly. Terraform is much more of a DevOps technology that I've recently started dabbling with. However, if you do run into Terraform, great, because we're going to talk about one of the biggest screw-ups I've made in recent history. And note, this is after 5 years of doing security work. Or I usually say security adjacent stuff. It's more like 2 years of actual security related work, and then 3 years of projects and volunteering and going into Athens and Prague for CTF events and all that other stuff. So, Terraform. What is it? Infrastructure as code. So, essentially, it allows you to define a file filled with a bunch of code, and then that code corresponds to, well, if you're in AWS, corresponds to EC2 instances, corresponds to container registries, corresponds to IAM roles, all sorts of fun stuff. Essentially, it allows you to build up your infrastructure as if it were code, hence the name. So you can actually deploy your entire cloud infrastructure in the span of about a couple of commands. And since I'm a person who really likes automating things, this is really attractive for me. And the benefits, generally it's consistent, assuming you know what you're doing. Dependencies are actually a lot less ambiguous in terms of like, hey, do we have like some random S3 bucket floating around somewhere? And also, if you need to change that, it's also really easy to do that too. And last bit, it's super automation friendly. I keep expecting the down key to be where the up key is, evidently. So you ought to hack 7. This is where I had my first real run-in with Terraform. I was on a team of 4 folks, and we were working on this massive Frankenstein project for entering entering the deep code, Solus, Grok, Terraform, and UI UX challenges. So that's 5 challenges that we were going into. And one of those was best use of Terraform. So I figured, oh, okay, cool. This is a great excuse to learn something I've been pushing off for years. So we got to work on that. And deep code challenge. So this was actually great. I was actually in contact with a gentleman from deep code, just kind of like getting a better sense of like what the requirements were, what he wanted, also seeing if he could help us out. And what wound up happening was he actually gave me an API key to use with Showdown. How many folks here have used Showdown before? Show of hands. Okay, good chunk of you. For the folks that haven't, Showdown is essentially a search engine for the internet. It used to be called the hacker search engine until some legal teams didn't like that. So now what it presents itself as is it's a way of scanning the internet, usually from a defensive security perspective, but still a lot of offensive security folks use it, and it's really, really good for finding information about domains, which is exactly what we needed, right? So we're talking, and then this guy sends me an API key, and I'm like, okay, cool, that's fantastic, thank you. We got a couple of our own API keys for other services. So this was the image that I got back after I asked him what the limitations on the API key were. So already, the stakes were a little bit higher than I'd anticipated, right? So this was like, okay, wow, really playing with some big stuff here. Now, unfortunately, I decided against using anything like AWS for this project in terms of Terraform config, because I didn't think I had the credits to cover all that. So we were just working with like pure Docker. And so this was pretty much the most expensive thing in our code base at that time. So I want you to take about 2 seconds as to how I messed this up. Okay, maybe a little bit longer than 2 seconds if you've never worked with Terraform before, but take a bit to figure out how I messed this up. No takers? All right. So Terraform, fundamentally, it has to keep track of your state, of the state of your infrastructure, right? Now, I was working with Docker, and I was passing in environment variables. Kind of broke my own rule about using Docker. Oh, sorry, go ahead. Yeah, I committed my state file. But yeah, well, I committed my state file. But essentially what happens is your Terraform state file keeps track of all of your changes in the cloud, right? So it keeps track of, what do you have available, what you might need to destroy going forward, all that sort of stuff. Again, I'm still a little futzy with it. I'm still very new to the technology. But essentially what wound up happening is I didn't realize what you had to git ignore before I started slinging code into the repository. So what wound up happening was, yeah, essentially, like I was using the Docker providers and then throwing the environment variables in there. And then obviously I was kind of breaking my own rule about using Docker secrets, but honestly, if it wasn't in the environment variables, they probably would have shown up somewhere else anyway. So yeah, this is how I wound up essentially compromising a $69 a month API key, and then some, as you can see. Luckily, I was able to actually let everyone affected know. I let the folks at Deep Code know that, hey, after this competition, you might want to rotate out that API key, because I don't know who's going to be checking Terraform state files, but I know it's not going to be anybody good. And then I also had to let my team know, hey, we're going to need to rotate out these keys once the competition is done. And so, yeah. Also, fun fact, I tried to hastily undo my mistake here by doing some weird operation with Git where it would essentially overwrite all the old commits. However, all that did was add a bunch of new commits into the repository, and still the file was there. So all that conundrum for nothing was really great to hear. But yeah, generally speaking, when you're working with Terraform, just look for a Terraform git ignore and then chuck that into your application. Honestly, it is a lot easier than the alternative. But there is another way, actually. And that's making sure your Terraform state isn't even in your code at all. So Terraform actually allows you to use a remote backend. So this is something like AWS S3, Azure Storage, Terraform Cloud, DigitalOcean Spaces, if you've ever worked with that. Any kind of those blob storage, file storage, remote file storage solutions will generally work. And then in the resources space bin, I do have some articles that link to how to get that spooled up specifically with S3, but the principles apply to other providers as well. General gist of this is, instead of going into a local state file, Terraform just chucks all the state into a remote file and then deals with it that way. So as long as your access control on that blob storage is good, then you're in a good spot. So good question. So this was off DigitalOcean, and don't mind the S3 here. DigitalOcean actually uses like an S3 compatible backend or an S3 compatible API for their object storage. But I've actually used a few. Right now, I'm working with Microsoft Azure, so I'm using the Azure storage backend. You could easily use, like, again, AWS. Terraform Cloud also has their own. So I'm not as big of a fan of using that because I like to use the open source version, OpenTofu, rather than Terraform, but to each their own. And this is just kind of like an example of what this config kind of looks like. I'm just gonna kind of skip past this because it's not super important to most folks, but I believe I'm not sure if the slides will be available after this, but if anyone wants to talk to me and is interested about that. Oh, what's up? Awesome. Oh. All right, so that is that. That's basically the end of the presentation. I'll share the QR code for the paste bin of resources shortly, but yeah, for now, thank you so much for listening. If anybody has any questions, now's the time.
Robert Babayev, wow, that's a lot of secrets that you shared with us. Does that mean you have to kill us now? Or?
No, I might be Russian, but no.
No. That was really interesting. Does anybody have an obvious question that they want to start with? If not, I have a couple. Really? All of that, there we go. There's the hands going up. First 3 rows back.
I know you touched on it a bit, but if you go into more detail about how one of the slides you mentioned that .env files aren't enough, can you just reiterate why that was?
Yeah.
Why aren't env files enough?
Yeah, absolutely. So .env files on their own, they're fine. The trouble comes in when you're collaborating, and then also, generally speaking, if you have like an open source project, anytime where other people are going to be working on this stuff, and also anytime where this code is going to be living somewhere that isn't your computer. That's kind of where .env files tend to break down, because then you have to start sharing secrets in other ways. And then you also have to start wondering, like, oh, how do I update this, right? Because it might not even be that things get compromised. It might just be like, hey, this API that we're using, they updated how they do things, right? Or we're adding a new API into the system entirely, right? So it might just be that, like, you need to literally just send everybody a new version of the .env file, and then, that's not great. So that's where things like secrets managers tend to come in handy.
And would you say, like, you said except for if it's only staying on your local computer.
Yeah.
Is that even enough? Like, if it's a home project and you're worried about your showdown key, maybe like it's not a huge deal. But if you're dealing with anything much more than that, you're still really storing secrets in plain text on your laptop, right? Which is, you could go a step higher if it made sense for you.
Yeah, it all boils down to threat model, right? Yeah. For those that are here for the first time, like never interact with security before, a threat model essentially is what you have, what can go wrong with it, and what you're able to do about it, right? So what you have in this instance would be a plain text file of your environment variables. What you can do about it, what can go wrong, generally speaking, I mean, if it's a file that you only have on your laptop, worst case scenario, somebody manages to break in, slots a USB stick with Kali Linux loaded on there, exfiltrates the data onto their drive, and then walks away, and they have your entire project on there. That's a worst case scenario. Again, most people don't have to worry about that unless you're Mr. Robot, and then in this case, why are you even taking my advice? But yeah, so what can you do about that? So generally in that case, I mean, disk encryption of any kind. So like something like Veracrypt or the Linux native solutions. Or
I think I'm just kind of getting at, like, at runtime, like,
Yeah.
if you get a hit at runtime with an info stealer, for example,
Yeah.
like, runtime data is not encrypted. So yes, an env file is probably fine for most of the development you're doing locally with a non-live key, but don't put your production key there if you can avoid it.
Oh yeah, no, absolutely. Like if you're anytime you're like putting in environment variables, try to avoid you like cross-contaminating your environments as well. I think that's also something really important to mention. Like just make sure that you're using your dev variables in your dev environment, your production variables in your production environment, everything in between.
Never the twain shall meet. I will say I've got a couple more questions from the floor here. I haven't really introduced the internet who's here with us tonight. So if you have a question online, Mel's here watching, and will let us know what your question is. There's one here, and then over here. Yes, Pittsburgh?
Yeah, I have a practical question about Terraform.
Sure.
When you start writing an application, let's say in Django, then you decide to create some infrastructure, and then to manage this infrastructure, you create a bunch of Terraform context. And you manage this infrastructure with this Terraform context. And then you want to push your Terraform state onto, let's say, AWS. And you end up with infrastructure for your infrastructure, for your application. And the question is, how do you manage infrastructure for infrastructure?
So the brain dead simple answer to that is just manually make the first bit of infrastructure so you can automate the rest. It's just there does need to be like a little bit of a little bit of manual effort first, but once you have that, once you have that baseline like AWS bucket, or worst case, like if you're using an AWS bucket as a Terraform state manager thing, right? I have a dedicated DigitalOcean Spaces bucket just for my Terraform state, right? And that can come across multiple different projects. That's probably a horrible way of doing it in terms of access control.
It's good to know.
But it does keep things isolated, and it also makes sure that, like if they're my projects, I have access to them. And it also prevents me from needing to like go and grab multiple buckets. So yes, there is some manual config involved just in that initial setup if you want to use the remote state. But outside of that, like one bucket versus the application that I'm working on right now with like virtual networks and network security groups and functions and databases, and I'll take the manual workload to save me some headache later, right? That's kind of the general gist of that. Great question though.
It sounds like it's an inception problem, and at some point you got to just start somewhere.
Yeah, exactly. It's that. Yeah, it's a great term for it. And it's an inception problem. Is just you kind of have to do a little bit of grunt work, and then once you're off the ground, Bob's your uncle.
Does it make sense to do this infrastructure in another cloud provider?
Depends on your use case for that. You can use the same cloud provider. You can use a different one. Most of it's just how much headache or, huh?
Or a different account?
Yeah, honestly, it's mostly a matter of just like, what's the right situation for you and how much headache do you want to manage? That's kind of like, that's where I'm going to throw out my first, it depends, because it really does depend at that point.
Which is, that's security all the way down, right? It's
Exactly,
like,
yeah.
How much headache do you want? Like the convenience and security are often at odds.
100%.
Often, not always.
100%.
And you might find more complex ways, and it might be simple enough to stay in the same provider.
Yeah. The important thing is not to find the overcomplicated ways.
Right.
Would you have any opinion on password managers that are browser extensions versus like desktop version of this?
Yeah, great question. Not necessarily about application secrets, but really great about password management and personal security. So question was, what can you recommend about password managers that have browser extensions as opposed to local clients? So there are two that I can recommend off the top of my head. One of those is Bitwarden. Bitwarden is honestly, the free tier that you get is like really, really good. And then the premium tier for like one person, for like 1 or 2 people is stupid cheap. It's like $10 a year or something. So that's a really, really good option if you're price conscious. If you're willing to pay a little bit more, 1Password is, I believe, 30-ish bucks a year Canadian. Granted, you do have to explicitly request Canadian on their website, otherwise they will charge you in USD, and you have no way to make that back, which is super annoying. But outside of that, they are legitimately a great password manager, and both of those have really good integrations with browser extensions. 1Password is a little bit trickier because it does require you to have the local client installed to even use the browser extension. But there is an additional layer of security on top of that, which I won't get into here.
That was my question actually, like, is there any like advantage of using a desktop client versus not using the browser extension?
Desktop client is arguably harder to crack. Outside of that, that could be an entire topic in and of itself.
There's a really awesome talk coming up in Halifax in a month or two on roughly that topic of like the different ways that browsers and password managers can get cracked by, I'm gonna say it again, info stealers. And so like, I think what you're tapping on is there's different attack vectors depending on where you're storing your passwords. And there's a very different between store it in your browser because your browser said store it there versus store it in a password manager, and then whether it's a password manager in the browser or an application based, like a bunch of different attack vectors. I suspect neither of us know the answer.
Yeah, it's as much as I.
Mia might.
Well, yeah, having tried it, I mean, not
Yeah.
really granted, a lot easier to find the ones in the part of the browser. Something like 1Password, much more robust.
Yeah, because it does have like that requirement of, you know, you have to unlock the thing that's on your computer before you even get access to the thing in your browser, right?
Yeah, the 1Password in the browser, there was a woman I found that go to Chrome and edit and grab everything in there.
Oh wow,
Very quick.
that's
Pretty
brutal.
quick, real quick. Yeah, amazing. Any other questions? Any other questions? Robert, thank you so much for sharing your knowledge with us. One more round of applause for Robert. We do this here every month after the talk over the next couple of days, depending on timing and Robert's graciousness. We will have slides. I suspect you will get a link available for those in the general channel of our Slack. If you haven't found our Slack yet, head to the meetup page that brought you here, and you'll find a link to our Slack community there. With that, do we have an announced date for next month at this point? I should know this by now. Third Wednesday of every month, except when it's not, I think is the rule. But most of the time, third Wednesday of every month, you should expect to see us here. We should hope that there will be pizza, and we hope to see all of you. Thank you very much. Safe home.